we're reaching through our Patreon paywall and bringing forth one of the exclusive AMAs. That's where Patreon members ask me anything at all that crosses their mind, not only by sending in their questions in advance, but also by accessing our recording live. Normally that's only for Patreon members, but today we're bringing that out for all of you to see. Hope you enjoy it. Chet.
Yes.
It's that time.
The time is nigh. Oh, the time is now.
Is now.
That time is now. Ya es la hora.
And now.
Mi gente.
Now. Yeah, it's exclusive Patreon Q&A.
Yeah.
AMA. Only they get to ask the questions, which is always true, but only they will get to listen to the answers.
Well, that's because they gave us the money.
No, because they support us.
Through money.
Okay.
All right.
What's that you said Quincy Jones once said?
Quincy Jones said,
nobody doesn't love Quincy Jones.
oh my God, Quincy Jones was a genius among geniuses.
You know, at the 50th anniversary NASA celebration, up at the other airport,
right,
in Washington, he was there, like playing music. I was there. He was there.
That's
the
very
astronauts were there.
Very cool.
Quincy Jones.
Yeah, well, he's got a saying about money. He
with
says,
a white piano. Yeah.
Oh, how else do you do it? I mean, anytime an event of any import is happening, you have to have a white piano.
Yeah, that is interesting.
And anytime you play for Trump, you have to have a white piano.
The brown ones?
I don't appreciate the mahoganies, the browns.
The brown ones are being deported
Where
right
are my
now.
black pianos? Where are my black pianos? My beautiful, beautiful black pianos that only play Trump Love to Prove songs. I love them. All right. Anyway, Quincy Jones said, when money enters the room, God leaves, which is
Nothing
awesome.
could be more true than that.
Exactly.
Wow. Okay.
Yeah. So
all right.
Here we go. Sanad Bayramovich says this. Hi, this is Sanad from Chicago, Illinois. With all the talk about us living in a simulation, when we look out into the cosmos, or even here on Earth, what are some of the phenomena we've observed that feels like features and feels less like features and more like bugs in the system? I love this question.
Ooh.
What a great question. It's like, okay, forget whether or not we're living in a simulation.
Okay.
Let's assume that we are. And then let's figure out the glitches in the Matrix.
Yep. And right in the Matrix, there's a scene where they're entering the building.
Right.
And because they're in the real world in that moment, in their real bodies.
Correct.
I think so. Is that right? Or
No, they're still in the Matrix.
They're still in the Matrix. And Neo sees a cat.
Right.
A black cat. And then
He sees it again.
and it said,
He goes, whoa, deja vu.
and Trinity says, what happened? It was just something weird. Don't worry about it. No, tell me what happened. I saw a cat twice. Was it exactly the same cat? Yeah. Did exactly the same thing? Yeah. Then that she knew it was a glitch.
So it was like, yeah, that was the glitch in the Matrix, and that meant that they were made and the agents knew where they were.
Yes.
Right.
Yes. In fact, that was the answer to a clue in a New York Times crossword puzzle a few weeks ago.
What?
Yep. How do you know?
No, I meant New York Times has a crossword puzzle?
All right. So a couple of things. So how much is the universe like the Truman Show? If you didn't see the Truman Show, they created this world for him, raised him in this world, and he had no knowledge or understanding of the outside of this world. And everyone in his world, his friends, his teachers, they were all actors.
Right.
Okay?
He was the only one that wasn't in on it.
In on it. And he goes out on a boat to the horizon, and then he gets to the edge, and it's a painted horizon.
Yep.
Oh my gosh.
Yeah.
Your world collapses
Right there.
right there and then.
And every flat earther was like, I told you! I told you! I knew it!
So the question is there anything when we got up close and it just wasn't real? Or was it fake?
Right.
Okay, that has never happened. But what does it take? It just takes the programmer to be just way smarter than you.
Right.
Okay, how much smarter are you than a dog? All right, smart enough so that...
What breed are we talking?
there is a difference among breeds. So I grew up with a poodle. Poodle's a smart ass dog.
pretty smart. Yeah.
I didn't know until I met other dogs. And I said, what's wrong with your dumb ass?
Yeah, a lot of dogs are dumb. I grew up with a German Shepherd, and they're pretty smart too.
You grew up with a German Shepherd, I grew up with a poodle.
Yeah, and then after the German Shepherd, we had a pit bull. And
Damn, what's wrong with you?
That was my father. It was his guard dog.
Okay.
But it was too violent to be on the company premises.
Oh, yeah, okay.
So the workers were like, hey, man, we're not coming to work with that dog here. So then he brought it home to be a pet for his kids. Right.
There you go.
What the hell is wrong with this man? And then my mother...
Safe for home, not safe for work.
Exactly.
Yeah.
And then my mom, it took over the... so I fed it every day.
Mm-hmm.
Its name was Butch, and it loved me. And anybody else that walked into the laundry room, because we had a very large laundry room, it would basically attack you. And so then my mother made him get rid of it, and he gave it to somebody. But
okay.
It probably gave it to Michael Vick. Anyway, sorry, I digress.
Where was I? Oh, we're talking about, are we in a matrix?
How smart are you than a dog?
Yes.
How much smarter are you than a dog?
You could devise things that the dog would never figure out.
Right.
Because you can go 1,000 steps ahead of the dog, and the dog would have no clue.
Right.
So it just takes a really smart alien to program the universe. And so the idea that we can outsmart someone who's way, way smarter than us, I think is unrealistic.
Right.
But there are other things you can look for. For example, if you've ever programmed a computer, there's a place where you put up the parameters. What's the speed of light? You put in that because you might need that later.
Right.
What is the value of pi? You'll need that later. What is the range of values certain changing parameters can have in your program? Okay? So, for example, if you have people who age, we'll say they can be as young as 0 and old as, let's say, 120.
Right.
You can't say infinity because that's not real.
Right.
Okay? So you put in something. Now watch. Suppose we find out that no one ever lives past 120. People do, we improve health. We keep improving it. People going like gangbusters, and then they hit 120 and die.
Right.
That's not normal.
Exactly.
There's something wrong. That's a glitch. That means we found the limits of the programmer's range of values that they had presumed for us.
Right. Exactly.
That would be a way to determine that. If no one ever lived to 121, yet a bunch of people died at 120, something's wrong.
Exactly.
Now, the cosmic astrophysical version of that, we have cosmic rays.
Okay.
These are high energy particles that come from across the galaxy and across the universe.
Yes.
Very high energy.
Yes.
We can plot how many particles have different energies. There's like a tail off of their energies. That tells you how energetic the things are in the universe.
Okay.
You can ask, suppose, these are really high energy, high. Suppose there's a cutoff.
Okay.
How do you get a cutoff? Maybe that's the limit that the programmer put in.
Highest value that was put in.
That was put in because they didn't think we would get to that high.
Is that gamma rays?
They would have the energy of gamma rays.
The energy of a gamma ray.
Right. So that's what I think we would need to look for.
Wow.
Otherwise, everything's going wrong just fine. And another thing, we're putting our bias on it. If you dig into the Earth, why would the programmer have to create the whole Earth if you're only digging into one part of it? So why not create the Earth you're digging into as you dig into it?
Of course. That makes sense.
Right.
It's like the old...
Otherwise, you're wasting computing power.
Right. Those old backdrops that would circle around and the people would walk on a treadmill and the backdrop's going by them and they're just walking.
Okay. Right. Because only the part that you're looking at is what mattered at any given time.
Yeah.
And that pissed me off watching the Flintstones.
Really?
Yeah. Because in the car, as they sped up with their feet, as they went by, the scene were exact duplicates of previous scenes.
Absolutely. That just kept repeating.
They kept repeating.
Yeah.
See, that would be a glitch in their matrix.
That would be a glitch in their matrix, yeah.
They say, hey, they should have had an episode.
Hey, Fred, didn't we pass that just 2 seconds ago?
Exactly. I would have noticed that, and I said, wait a minute, I think we are drawn by somebody.
Right.
And that's the same with Jessica from Roger Rabbit.
Oh, Jessica Rabbit.
Jessica Rabbit.
I'm not bad. I'm just drawn that way.
I'm just drawn. So she has self-awareness that she's drawn. Right. So that would be a way to do that. We have yet to see sort of duplicated scenes or anything like that.
Yeah.
Which would show the laziness of the programmer.
The programmer.
Right.
Okay.
All right.
Cool. There you go. Nice question there. Let's go to Steve Hale. And Steve says, hey, Dr. Tyson, Lord Nice, I am a retired family physician, worked mostly in public health, and a recent Patreon subscriber. Well, thank you for your service.
Yes. Service and support. Yeah.
My question is to Lord Nice. What? Uh-oh. Why didn't I skip this? I should read these beforehand. I swear to God. All right. Does he recall in childhood being required to write his last name first, then comma, then first name, therefore Nice Chuck? Yeah. And did he have any feeling or reaction to this? Maybe, why are we demanding Nice Chuck? I will become a comedian and poke fun at them and create laughter. That's not exactly how it went at all. By the way. And no, the only problem with being Chuck Nice is very hard to be a dick when I want to be.
Oh.
Yeah. The moment I'm a dick, people are just like, I knew it. Yeah, you're not nice.
You're not nice, yeah.
Or Louis Ferranda, who was the general manager of Caroline's on Broadway, used to call me
Caroline's Comedy Club.
Caroline's Comedy. Used to call me Chuck Mean. He said, because I know your secret.
What's the secret?
That I'm not nice.
Okay. Okay.
Chuck Mean.
Yeah, but when you did do Nice Chuck, did what thoughts went through your head?
Nothing, because I don't really know if I'm nice to this day. I mean, I think I'm compassionate, but I'm not sure if I'm nice.
You know, nice didn't always mean what it means today.
What's that?
Nice meant honed with precision.
Whoa!
Yeah. If you had,
I wish I had known that.
No,
because that's what I've been thinking.
So because if
I am German.
What?
Honed with precision.
German engineering.
German engineering.
Okay. Yeah. So if you had a nice knife, it meant it was sharpened and could perform its task.
Get out.
Yeah, and then nice became a desirable feature of things that were nice, and then it just turned out to
be a nondescript word that we have slap on everything.
Right. This has lost its precision.
That's very cool.
Yeah.
I did not. Honed with precision.
I think I'm right there.
I'm going to look it up.
You going to check?
I got to check right now because that's too good not to know.
Not to bring with you.
By the way, how do you remember this stupid stuff?
No, because I'm right, and so I care what the words mean.
This is true. I've read your writing, and I'll say that it shows. I'm going to give you that compliment.
So the origin...
When you write, you definitely are a person who chooses words.
Oh, yeah.
You are a word choice smith.
But I choose words not what sound good coming out of me, but what work landing on you.
Ooh.
As an educator, I care about you. I don't care about me. Right.
Okay.
Did you look it up yet?
I have precision.
No. Just look. Original early definitions of nice or obsolete definitions.
It appears to be.
I mean, I could be wrong, but
nice as honing likely. Okay, no.
Don't do
that.
Don't lead the witness.
Don't. You know why? Because it's AI. You can't.
Yeah, AI. You can't. Okay.
Nice original
usage.
Here we go.
What do you have?
Dainty and luxurious.
That's interesting.
Delicate as a distraction.
Okay. None of those are what I'm
saying. Modern, polite.
Yeah.
Amelioration. None of those are good. Oh, shit.
What?
15th century.
Yeah.
Precise. Precision. Before finally becoming a term of pleasant kind approval. So the precision, which is
worked its way
to being like, oh, I approve of that. It's so precise.
Yes, there it is.
So now, since I approve of it, now just the approval part was what we use now, which means,
it was nice.
Right. Okay. The original, which is so funny, The original was just the opposite, which means ignorant or stupid.
No, that's not what that's.
T-Mobile 5G home internet has some big news you should know about. They now have the fastest 5G home internet according to the experts at Ookla Speed Test. Now, in practical terms, it means photo backups happen faster, streaming a documentary doesn't stall halfway through, the physics of waiting reduced. What's also notable is that this jump in speed doesn't come with added complexity. Setup is simple. You plug it in and you're online in less than 15 minutes. And the value side of the equation holds up too, with a plan price that's backed by a 5-year price guarantee. So, if you want the fastest 5G home internet with a simple setup and savings that stick, get T-Mobile 5G home internet. Just visit t-mobile.com/home internet to check availability today. Price guarantee, exclusions like taxes and fees apply. Fastest based on Ookla Speed Test intelligence data, second half 2025. All rights reserved. This is Valalov. Tommy from Stockholm says...
Stockholm, Sweden.
Sweden.
Oh, by the way, you know, the Nobel Peace Prize is given in a different city from all the other Nobel Prizes.
Get out.
Yeah.
Why? Just to make that distinction?
I once knew, I don't remember.
Okay.
Yeah, so all the main ones are given in, the quote, regular ones are given in Stockholm.
Stockholm.
And then the Nobel Peace Prize, there's some other city, I forgot which.
Okay.
Just to put, okay,
right.
Go on.
What is the last video game you have played, Dr. Tyson, and what's your favorite game ever?
Wow. Mm-hmm. Okay. So I was never into violent video games. We had to harm
other people or other things.
Mm-hmm. And I didn't even like Pac-Man because you had to like eat
right, the other little creatures.
Right. And I thought, not that I had some deep philosophical objection to it.
Yeah.
It was just not entertaining to me.
Okay.
But you know what was entertaining to me?
What?
Tetris.
Oh, of course. It's a puzzle game.
Oh, yeah. Mm-hmm. Tetris was good.
All right.
And that probably, by modern standards, doesn't even count as a video game, right? It's a video distraction.
It did at one point, no longer.
Yeah. So I'm not the video game guy.
Yeah.
I'm not that guy.
Yeah. I've never played video games. So.
Really?
Yeah. I had friends who would play and I would watch and I just didn't. I always felt like we should be talking to girls right now. What are we doing, guys? It's dark in here. The only thing lighting this room is the glow of this sad television set. We should get out of this room and find girls to talk to. And honestly, that's how I felt about video games. And to this day, whenever I see guys playing video games, I'm like, you have a girlfriend. You should be having sex with her right now. Why are you doing that? So anyway, yeah, just never played them.
All right. All right. Well, maybe they're all gay, and when you're not looking, they have sex with each other.
Well, my point is, skip the game.
Okay. Either case.
Yeah, okay. Yeah, skip the game.
Yeah. Right. So I don't have a rich answer to that question.
All right, here we go. This is Michael Stoerzer, who says...
You're so bad with people's names. You don't even sound like it could be pronounced that way.
It probably couldn't. But Michael knows who he is.
Let me see.
Michael knows who he is when I say his name.
He know who he is? Mm-hmm. Michael Storzer.
Oh, okay. I was close.
Storzer.
But Stoerzer. Okay, here we go. Back on track. Mm-hmm. Here we go. Sorry. Tamsin is chiding us.
Taskmaster
Tamsin. Mm-hmm. Okay, Michael Storzer says this. Hey, could these fully formed galaxies seen by the JWST that seem to be too early in the Big Bang timeline, in fact be fully formed galaxies that is in an adjacent universe that we can see due to this overlapping of universes? By the way, you guys crack me up. Go ahead. Yeah.
I'm going to not rule that out.
Yeah, really?
But we don't have other evidence of overlapping universes.
Right.
And we've looked.
Right.
We've actually looked for this. Mm-hmm. In the cosmic microwave background is a very detailed map of everything the universe was doing when it was 380,000 years old. Mm-hmm. If another universe went bump in the night against us, we would see some kind of imprint in that background, and people have looked. They've looked to see if the universe doubles back on itself.
Right.
Because maybe you look this way, but something behind you is showing up in view.
Exactly.
Okay, so it wouldn't even have to be another universe.
Right. It could be the same universe that you're seeing as it coming around.
Coming around.
Right.
And so there's a way to do this statistically. You grab a piece of that pattern because it's all around you, and then you map it in all different orientations onto every other possible place that could be mapped, and we don't see any evidence of the meddling of other universes within our own. So I think we just have to go back to our own, how do you make a galaxy drawing board, all right? Because the Big Bang is very secure in all the ways that we recognize that's telling us what's
the
really
evidence of everything that we believe about it is
strong. And varied. So whereas we built the James Webb Space Telescope to see galaxies being born. That's the whole point of it. So the fact that it found something that, well, we don't know who ordered that. Right. It's doing what we asked it.
And can you talk very quickly, because I know that there are people who get confused because the timeline is the same. The galaxy is born. So how are you seeing it being born? Can you talk about what happens with light?
How is it we can see?
How is it that we can see back in time with light? What happens?
We see the universe not as it is, but as it once was, according to the light travel time from those destinations. I see you not as you are, but as you once were 3 billionths of a second ago.
I have changed so much since then.
Relative to human life expectancy, I don't have to worry about that.
Right.
But on a time scale of the universe, the time delay is long compared with the lifetime of stars and galaxies and other phenomena that unfold. So,
and what specifically about the wavelength of light?
No, it's not wavelength, it's just speed.
Speed of light.
If the speed of light were infinite, we would not see anything in the past. And there'd be no such thing as cosmology. We have no knowledge of the formation of the universe.
Then why do we have different lights? Like, why do we have X-ray, infrared?
Oh, there's just bands of light, but it all goes at the speed of light. We can use any one of them.
Okay.
We're good. It'll tell us different things that were happening at that time, because different phenomena give off different amounts of each of those kinds of light. Like the cosmic background, that's microwave.
That's microwave.
Yeah, we have we didn't know that until we had a microwave telescope.
The microwave cosmic background radiation.
Exactly. Right. Galileo didn't have a microwave telescope. He ain't thinking cosmology. All right. By the way, Galileo was the first person to attempt to measure the speed of light. He put his servant or whoever on a mountaintop with a lantern with a shade, a shutter, and he went on another mountaintop, and they would time it, and you know what he said at the end? I'm paraphrasing, but it went something like, light, if not infinitely fast, is faster than anything we can figure out by this method.
That's very cool.
Yeah.
Wow, that's very cool.
Yeah, but he knew enough to even ask that question.
I mean, what a great, wow. What a mind. All right, speed round. John Haverlack says, greetings, star nerds. My name is John Haverlack, signaling.
Thanks for the compliment.
Yes, from Fairbanks, Alaska. My question is.
Where my wife grew up.
Yes,
Fairbanks, Alaska.
That's correct. I'm saying that's correct, like you don't know.
Thank you for affirming what I said.
You knew where your wife was born. Consider the meaning and context. He says, Hotel California, the Eagles, 1977, black hole. Consider the meaning and context. Approaching the event horizon. Up ahead in the distance, I saw a shimmering light. My head grew heavy and my sight grew dim. Interior observer. Any time of the year, you can find it here. Her mind is a Tiffany twisted holographic information. We are all just prisoners here of our own device, mirrors in the ceiling. Singularity, we stab it with our steely knives, but we just can't kill the beast. You can check out anytime, but you can never leave. Is this a cosmological comparison or a casual coincidence? Thank you, John. Now, I'm going to say this, John, and first of all, and I mean this with the utmost respect, you need to send me some of these drugs.
I mean to say, there was a period of time.
I mean, damn.
There was a period of time between and I've thought deeply about this.
Okay.
Between like 1970 and a half and 1973.
Okay.
Okay.
All right.
In that, when was Hotel California written?
I think he says 77.
That late?
I think so.
Oh, wow. Okay.
He says here 77.
Okay, I have no reason to doubt that. But in that period of time, rock groups wrote lyrics that made no freaking sense. But if you got high or were otherwise
They got
drug
deep.
induced, they were being deep.
So deep.
And so the fact that sentences and words rhymed but otherwise made no sense was used as evidence that it made sense in a deeper
State of consciousness.
state of consciousness.
Right. An altered state of consciousness. You're absolutely right. Yeah.
Okay. And so, and I'm allowing this to be art for art's sake.
Right.
And
And if it means that to you, then it's a black hole.
that's where I'm coming
There
on
you
that.
go. If you got black hole out of that, man, guess what? Good
more
for
power to
you.
you.
Good for you. As long as you think it's scientifically, we don't care. However you're inspired.
Yeah,
You
exactly.
know, however you're inspired to think about the cosmos, that's great.
We'll take it. We'll take it whatever way
If
it
you
works.
drop some acid and listen to the Eagles, and all of a sudden you're in a black hole and you're being spaghettified, and you're like, this is amazing. I can't believe, look at my, oh, shoot, I'm being extruded through time and space. Guess what? That's great. That's fantastic. All right.
Since you mentioned that, just a quick fact.
Go ahead.
Like right about now, we're releasing an audio original, a 5-hour conversation I had with William Shatner.
Wow.
It's on Audible. 5 hours
Yeah.
in his backyard.
Is that edited 5 hours?
Yeah, I probably went 6.5, but it's down
Okay,
to 5
they're
hours.
down to 5.
Oh yeah. It's tight conversation. But in there, we're talking about black holes, and he said, "Is it true you want to die in a black hole?" And I say, "No. If I had to die,
Right.
that's how I would choose to die.
Exactly.
I'd say I'd be spaghettified." Then he asked me, "Why won't you be linguine?" No one had ever asked me before what kind of pasta I would be
you like to be?
falling into a black hole. And I said, I never thought about that. And so I told him, I said, well, I want to be fusilli.
Ooh.
So I can twist my way.
Twist your way around.
Corkscrew into the black hole.
Also, fusilli is it sounds romantic.
Yeah.
Fusilli.
Yeah. So it's called Cosmos Confidential.
Cosmos Confidential.
Yeah.
All right, look for that, guys.
Neil and Bill's excellent bromance.
That's funny.
Yeah.
All right,
Okay, go ahead.
Alejandro Guardado. See? He says, hey, Dr. Tyson, Lord Nice, 18-year-old Alejandro here. Or should I say, Alejandro from Washington State. My question.
That's not as like cool if it's from Mexico.
No, it should have been from Mexico. but you call it Washington State.
Go.
He says, what is the color just between violet and ultraviolet and red and infrared? I know it's a part of the light spectrum, but at what point do we stop seeing the color? Thank you for making the world a better place.
Well, thank you for thinking that, Alejandro. So,
you killed my father.
What's that from?
That's the Princess Bride.
Oh, is that right?
Yeah. You killed my father. Prepare to die.
I don't remember that. Okay.
Anyway, it's not. Go ahead.
You look at the cones of our retina,
Right.
which have 3 pigment sensors. Red, green,
RGB.
and blue.
Right.
It's RGB. It's why we know anything about RGB.
Exactly.
We're mimicking our retina.
Right.
And they have sensitivity curves. So right in the middle, they're most sensitive, middle wavelength. And as you go off to each side, they become less and less sensitive. As you go off this red side, there's a point where you stop seeing what's there.
Right.
But there's still something there, as discovered by William Herschel. And he called it light unfit for vision. And its thermometer there went higher than any other color. He said, the sun is, I can't see it, but clearly there's some action there. We call that infrared, below red. You ask what color it is no color because you can't see it. Right on the border of the red pigment of your cones, you don't see a damn thing.
Wow.
You can feel it. Your
Right.
skin can detect it. Your retina cannot.
Right. So you feel it as heat, but you can't see it.
Can't see it.
And even when you think you can see it, you're not seeing it.
Correct. In fact, infrared lamps,
Right.
you're seeing the part of the infrared lamp that's giving you red light.
That's right.
But that's not the
That's not
infrared.
the infrared.
That it's going. Right. If you bring infrared cameras in, it'll be way brighter
Exactly.
in the infrared than it would be in the red.
Yep. Okay. Very cool. That's the answer. That's a great question.
So I enjoyed that.
That's always
Those
fun.
are good questions. Oh, yeah.
I love doing these things for especially when they can ask anything they want.
Yeah.
You know, like, hey, I just dropped some acid and am I in a black hole? Man, my favorite question so far. That's my favorite.
Brad Luster, hey, man.
Hey, guys.
Brad Lester.
How you doing?
Hey, you calling in from where?
You got two first names, man.
Luster?
You got Brad Lester.
Yeah.
Oh, Lester or Luster?
And they're both pretty stereotypical American names, too.
Oh, Lester, yeah, okay.
Yeah,
I'm-
Brad Lester.
I'm from Minnesota.
Minnesota,
So-
ooh.
Oh, man. Well,
Ooh.
God bless you out there in
Man.
Minnesota. I'm not going to get political, but we stand with Minnesota, the people of.
Yeah, it's hard to kind of describe without using a lot of expletives.
Yeah.
So,
Yeah.
you know, it's rough, but we're hopefully going to get through it.
Yeah.
We will.
But
Yeah. Or it'll get through us. One of the other. Okay. All right. So what you got for us?
so I do have the science question
Sure.
because this has been bugging me for a while. It's about a couple of slightly related concepts about which I've heard you speak a couple of times. The first being that the fabric of space-time might be woven by microscopic wormholes.
Yeah. I'm still losing sleep over that, but go on.
And then the other one is how we might create our own artificial wormhole and how it requires like negative gravity substance or process.
That's it. That's the 100% of anything I know on those two subjects. So,
Gotcha. Well, my question is like if both of those prove true, it seems to me like space-time's natural state is to always be expanding, because if wormholes are always pulling space-time apart, and space-time is made of wormholes, it seems like the nominal state is for it to always be expanding, which sounds a lot like dark energy to me. Am I misunderstanding any connection
All right,
there?
so you are perfectly understanding the situation.
Absolutely.
So here's a little bit of the backstory. So we see the universe is expanding, and it's accelerating in its expansion, implicating dark energy, predicted to exist as a thing in Einstein's general theory of relativity, which he published in 1915. Einstein looked at this term in his equation and it says, this is a negative gravity term. It can't be real. It's probably just zero. So let's ignore it.
Right.
Okay, how could there be a negative gravity? That we haven't seen any, we don't have any evidence of it, yet it came out of his equations. It is possible for equations to have solutions that don't correspond with reality. Okay, I'll give an example. Let's say I'm on a cliff, and I toss a ball to you. Not a high cliff, but so I toss a ball, and it makes an arc, and you catch it down at the bottom of the hill. Okay, there's an equation that describes that arc. There's an equation. I can know with high precision, using Newton's law of gravity, Newton's laws of motion, using a little bit of mathematics, that this will take the shape of a parabola, okay? And I solve it, and I know exactly where you need to stand to catch that ball. Wait a minute, a parabola is a quadratic equation. Quadratic equation has a square term in it. If you have a square term, then the solution is the root of that term. Then I only found one of the solutions. Every equation that is in a square has two solutions to it. Where is the other solution? Well, you just discard it because it's irrelevant. But it does mean something. Oh my gosh, you know what it is? That's where you would have to stand if I were not on a cliff and I extended the path of that ball backwards. If you were standing on your same elevation below the cliff, but if the cliff were not there. So so the math captured that, even though it was not a real thing in the universe I was working in. Okay, did that make any sense at all? Did you follow that?
That's because you would input like a negative value, and a negative value squared becomes a positive.
Correct,
right?
correct. And so the negative place on this grid is behind me, down on a platform that doesn't exist because I'm on a cliff. But that would be the second solution to that equation, which I discard because it doesn't apply to me throwing the ball to you. Okay? All I'm saying is that the mathematics of physical phenomena can, on occasion, give you a result that's not physical to what matters.
Okay.
So this, it's called the cosmological constant, requires negative gravity. Einstein says probably nothing. Let's not worry about it. So while I was in graduate school, we always had to toss a bone to it. We do a cosmological calculation. Is what are you assuming for the cosmological? We're assuming it's negative. We're assuming it's zero. Right. Okay. Until it was discovered that it's real and it has value. Okay. Getting back to your question. Where does this come from? Oh my gosh. Well, quantum physics says that virtual particles are popping in and out of existence. That could put some kind of pressure in the vacuum of space, later interpreted as mini wormholes through entangled particles, but this is the same idea. If you calculate how much pressure these particles would create in the vacuum of space using all known laws of quantum physics, you get a pressure, just like you were suggesting. You get an answer. The problem is, it's the wrong answer. It is off by more than 100 orders of magnitude.
Okay, well, that's not good.
That's not good. It is the biggest mismatch between an observation and a calculation ever. And so we're still scratching our heads over this. So the answer is, we hoped it would be this phenomenon you're describing as the cause of dark energy, but we cannot square the circle. We cannot reconcile what quantum physics predicts and what we measure. So watch that space.
Gotcha.
Interesting.
Cool. Well, thank you very much for your time, guys.
All right.
And I really appreciate what you do for us.
Okay, excellent. Thanks for that.
Great
that
question,
support.
Brad Lester.
And stay safe out there.
Definitely. Yeah.
Oh, yeah, absolutely.
Hey,
All right.
listen, we're with you, man.
Okay.
You know,
Thank you. Appreciate
right.
it.
Dennis Schrader? Dennis Schrader.
It's Schroeder.
Schroeder.
actually.
Schroeder.
It's okay. Some census takers in Kentucky had some fun with us back in the 1860s. So, well, gentlemen, great to meet you both. I've been watching
Wait,
for
do you
about
own a
year.
cat so you can have Schroeder's cat? Just wondering.
I do have a cat. Yes,
His Schroeder's
and
cat?
let me tell you, there are many times when he tempts me to determine whether he's alive or dead.
Okay, so what you have?
So, gentlemen, first off, I've been watching for about a year on YouTube. I just started back in September as a Patreon supporter. I'm going to see you in May when you come out here to Seattle. By the way, go Hawks.
Okay, Seahawks, yeah.
Go Hawks.
You guys, I'm a lawyer by trade, but you guys have inspired me to return to my original love. What I started off for my freshman year was in science and engineering. I'm going to go back to school and study physics again. So,
Whoa.
thank you.
And you blame me for that? Oh, okay, I'll take the blame.
I thank you for that. I thank you for that. So,
Oh, and one other thing. Seattle
Yes, sir.
is my deepest fan base in the world. You know this. So when I
I
go
see
to
a lot of this on the comment section. Yeah.
Yeah. So when I go to Seattle, it sells out in like an hour.
Wow.
And so the theater said, put in another show. So I'm giving, anytime I go to Seattle, I'm giving 2 shows. And they're different shows. They say, I'll give a different show.
That's great.
Right. Because I give them a list of like 15 topics I can speak on, and they pick. So they don't want me to give the same show. It's a different show. So you can go twice.
Wow.
Yeah, they're trying to maximize, what. Anyhow, so thank you all for just who and what you are as a community. The university is there. It's helped set some of the mood of curiosity that pervades you all. So thank you.
Thank you. So I've written out a question regarding black holes and time dilation. You and others have said that as an object approaches the event horizon of a black hole, time appears to stop for them from the perspective of an outside observer. But time moves normally for the person crossing the event horizon. And if looking outward, that person would see the rest of the universe's time fast forward, basically see the entire future history of the universe, as you've put it.
Yes.
But from my perspective, that person just kind of stops. So if the person crossing the black hole, just because they've pressed the fast forward button, doesn't mean the rest of us don't still have to watch the rest of the movie at regular speed, right?
Correct.
So far, so good.
Wouldn't that mean wouldn't that mean then that nothing has actually crossed the event horizon of a black hole because the universe still exists? And how do we sort that out with the fact that we know we've seen things like black holes merge and we've seen the result of that merger?
That's brilliant. So I had that same question and I could not answer it based on my foundations of physics and cosmology. So we had Jan 11 in the chair.
That's right.
And I asked her that question.
That's right.
Because I couldn't answer it. And by the way, there was a book published in the 1970s by New York Times science journalist Walter Sullivan. Back then, journalists wrote a lot of the science tracts, not scientists, because it was not a thing scientists did much.
Because scientists were like, we're too busy doing science.
That's right.
We don't have time to write articles for you for your enjoyment.
He wrote a book titled Frozen Star, which was about black holes and not crossing the event horizon. So what Janice said, which this is the first I had learned of this, as you near the event horizon, you are no longer a separate thing from the black hole itself. And what happens is the black hole's event horizon ends up wrapping around you, merging with your event horizon. But I don't know why you would have an event horizon. But there's some merging of the geometry that takes place at the surface so that you're not stuck there forever from the point of view of those looking in. You will actually get absorbed and you will see that happen. And so that's a Jan 11 thing. And I'm going to have to ask you to go dig that up in our archives. Just find anything with Jan 11 in it and they're all good. But we're pretty explicit about who the guests are and who the experts are. So in our archives on our website. But so I'm waving my hands with that answer, but that's the answer. But you're otherwise thinking exactly the right way. That if this must be true, then this other thing must be true, and if it's not, how come it's not?
Yeah, and the other thing, I don't know if maybe the way I think of it is right or wrong, but it's always both are happening simultaneously, although they are separate one from the other. So it's based on the observer. So as the observer looking out, you're seeing all this go by, but you're just looking out.
Everybody's got their own
Everybody's
little
just
world.
got their own little world,
Yeah,
and these little worlds exist simultaneously, and that that's kind of like the way I have to think about it.
But what's the title of that movie? Everything, Everywhere, All at Once.
Everything, Everywhere, All at Once. Yeah, that's kind of how it goes down. Yeah.
All right. So thanks for. Sorry, I couldn't give you a deeper, more nuanced reply, but that is an answer that we did recover from our archives.
And
thank you, gentlemen. I've been going through the Patreon archives, so I've gotten all the way through 2019, just starting into 2020.
Whoa!
Good for you, man.
Oh my gosh!
I want to do my homework before I meet you in February or in May.
Okay, excellent. We'll look forward to seeing you there.
Yeah.
And bring folks too. Do you have any kids or anything?
Oh, my wife's coming with me. Yeah.
Okay. All right.
She's a big fan too.
Excellent. We'll see you there and then.
Well, good luck with the cosmological pursuits, my friend.
Thank you, guys. Take care.
All right.
Okay.
Here we go.
Sorry. Hey.
Joel!
All right.
What's up, buddy?
My question is about Star Trek. I'm filming this. This is January 2026, whenever people are watching, and I'm filming this from Minnesota. Right now, there is a lot of conflict between people who live here and authorities in the government. And Star Trek has this idyllic future where they've solved those problems, where there's conflict like crazy in Star Trek, but it's not humanity fighting against itself, especially not people against their own government, different governments, struggling for money, struggling for inalienable rights, human rights. They've solved those things. So my question for you, Neil, is have you thought about this? What might be required for humanity to reach a future like that?
I love that. That's a beautiful, timely, insightful question. And I can address it even if I can't fully answer it for you. I'll get 80% of the way there. So, space exploration in general, if we turn the solar system into our backyard, there are unlimited resources there. So, if the world has access to the unlimited resources, then wars over access to limited resources would become a thing of the past. That doesn't get rid of all wars, but it gets rid of a category of war that has reared its ugly head throughout the history of civilization. So there's value to that. Now let's get to the Star Trek model. my read of Star Trek, and I would need the Geek in Chief's blessing on this analysis. My read is the main thing that stopped wars was the replicator. Okay? So it's related to limited access to resources. It's related to that, but it has an even bigger solution to it. So I have an orange and Chuck wants the orange. I say, no, it's mine. If you're nice to me, I'll split it in half, but then we each only get a half an orange. I put this in the replicator. It makes an exact duplicate of that orange, and then we both have oranges. The idea that you don't want other people coming into your country has foundations in the idea that we have resource and opportunities that they don't, and they're going to come take it from us, and then we'll have less. And wherever they're coming from, they don't have these opportunities. So I don't think it was some higher evolution of moral. I don't think it was a higher moral evolution that is represented in those Star Trek storylines. I think it's the simple fact that nowhere in the world are you without resources, because the replicator provides it for you, period. And so you don't have to cross borders to gain access. You don't have to fight your neighbor. You don't have to do any of that. And so what it means is now you have just regular old evil people, just people, people,
you don't have an excuse. You're just evil.
You're just evil. You're just evil. And so, so the United Federation of Planets is now unified, and they're fighting evil forces elsewhere in the universe. So I think it's the replicator. And does that violate some laws of physics? Not really. You need a source of energy to turn the energy into matter and exactly duplicate the atomic and molecular form of what it is you're duplicating. So can that happen? Not in the foreseeable future that I can imagine, but that would certainly end wars over those reasons. I think there would still be tribal wars. People will still want to harm one another. Chuck and I can talk all day about the slave trade and man's inhumanity to man and the lynchings in the South. We could talk about that. However, if you take a step back and you look at the slaughter that went on in the First and Second World Wars, which was basically white Christians killing other white Christians, it's pretty clear that the person doesn't have to be dark-skinned on a gender spectrum or any other reason that people have otherwise invoked to commit harm. You don't have to be that, because they would find other reasons to do it anyway. All right? And so that is disturbing to me, at least.
Absolutely.
That's in our genes.
Yeah. There's a definite part of our evolution that has placed us in a position where territorialism, violence, these things are part of our lizard or monkey brain.
No, monkeys are not that evil.
Yeah, monkeys aren't that evil. Our lizard brain.
Stop insulting the monkeys.
Yeah. Well, there is one monkey that we very much resemble, even though we are apes, and that is the baboon.
No, baboon's an ape.
Yeah. Oh, I'm sorry. Yeah,
I'm
baboons.
pretty sure baboon's an ape.
We're the great apes. I'm sorry. The baboon is a lesser ape. So
I've known some apes that were pretty great. I thought.
So, but baboons are awful. I mean, they're just assholes.
No.
I mean, seriously, if you can do any reading on baboons, you will see how similar, in some ways, some respects.
Okay, that's true.
We are very similar in some respects.
I was in Kruger Park, which is a game park in South Africa.
Okay.
And I'm on a veranda eating my breakfast. Baboon came over and stole my bacon.
Oh, yeah. Yeah.
Came right up to my table, stole my bacon.
And you let it too, because it was a baboon. But they are, it almost looks like
he knew it was my bacon.
Yeah, it looks like they're, and sometimes they present as if they're incapable of cooperation.
Okay.
They will form a bond and then immediately backbite, which is where we get that term, by the way, backbiting.
Oh, okay. I didn't know that.
They literally bite each other on the back.
Okay.
But I think that education is one of the things that elevates us beyond. It gives us the opportunity to go beyond what we might be.
I think
in a
the
natural
Nazis
state.
in Nazi Germany were fully educated.
No, I don't mean that kind of education.
Okay.
Okay. So there's something about indoctrination when
We have a susceptibility.
yes, we have a
to-
susceptibility to
Yeah.
indoctrination. And
You know what else we're susceptible to? Why is it that we need hardly any proof to believe a lie, but we need all the
so
proof in
much
the
proof
world
in order to believe the truth.
to believe the truth?
Yeah.
That's scary.
It is scary.
Yeah.
So, but what I'm saying is, you put all those things together, that it takes a great deal of maintenance from a very like young age all
Maintenance,
the way
that's the
through.
word.
We need
Yeah.
maintenance.
Yeah, yeah.
And as our psyches require maintenance, and I think if we do that on an individual family level, that we help. Believe it or not, the numbers are not as bad as we think they are. We tend to think that there are more people in the world who are racist and xenophobic and tribalist than there are people who are like bonobos looking to cooperate and love one another. And I think the numbers are very even, and there may be slightly more on the side that we would call good. You know, even though I don't believe in the
Maybe without that, we wouldn't survive as a species.
yeah,
at all.
we definitely
we
would.
have to edge it out.
Our
Yeah.
greatest superpower as Homo sapiens is our ability to come together, cooperate, and achieve things in groups. That is our greatest ability.
Chuck for president.
So, you know, if you look at that and we cultivate that and we maintenance that and we drown out the other voices, then the susceptibility
Will go away.
will lessen.
Yeah,
And that's what I think really we need to do.
All right.
Okay.
We got to move on.
We gotta move on.
Okay. Thanks, Joel, for checking back in.
Thanks, guys.
All right. Good. Mm-hmm.
Joel, always a deep thinker, that Joel.
Yeah.
Hi, Dr. Tyson, Lord Nice. How are you?
Hey, Ryan.
Good to see you. I had a question actually following up on Jan 11. One of my favorite episodes you guys did was last year when she came on and you talked about Einstein's different, the crumbs from Einstein. And Dr. Tyson, you made a comment about you can develop like mathematical equations that don't have a basis in our reality. And I'm just wondering if you could kind of expand on how that works, because I have a very basic understanding of math, and that's a whole
Okay. Yeah, this is an important thing. And Chuck, maybe we should do an explainer on this at some point. Okay. So let's think of mathematics as something that was out, you know, people like debating, is it invented or discovered in the universe? And I don't join those debates because that becomes semantic. And why have a debate over words that are describing something that has such high precision as mathematics itself?
Right.
Why use...
The truth is, it don't make a difference.
Doesn't make a difference. Exactly.
Whether it's invented or discovered makes no difference. It
To the
works
math.
better than anything.
Correct. So,
Thank you for that a difference.
mathematics is precisely logical and defined and effective. Okay. Put a pin in that. Now we look around the universe and I see phenomena that repeat. And I see others, and I ask myself, is there a kind of math that I could attach to what I see so that I can manipulate the math and in a way manipulate the universe itself?
Ooh, okay.
Okay.
Yeah.
So, as I said earlier to a question, if I now understand gravity and I want to toss a ball to you, using Newton's laws, I derive an equation that tells me exactly where that ball is at all times on its arc.
Right.
That's pretty powerful.
It is. It's a very precise language.
In fact, I'm not just describing what I'm looking at.
Right.
I'm predicting where it will be.
Yeah.
Okay. So that's math matched to the physics. All right. Put a pin in that. We first put a pin in the math. Now I have some physics to apply the math to. All right. Wait a minute. Suppose my idea of the universe is flawed. Well, if I take math and attach it to that idea, the math is perfect every time. But who's to say that my idea of the universe is properly represented by the math I'm attaching to it? So Einstein comes up with a general theory of relativity which talks about the curvature of space and time.
Okay. Yes.
He doesn't know enough math to do that. So he pulls in some topologists and some geometry people, and they help him find the math of curved space, curved geometries. It's called non-Euclidean geometry. Non-Euclidean means space that's not flat. Most geometry you learn in school, it's Euclidean geometry, whether or not they tell you that. It's just flat.
Right.
Parallel lines meet at infinity, whatever that's supposed to mean. Okay. Triangles, that's Euclidean geometry. Non-Euclidean geometry, we curve the space-time, now still do math on that curved surface. That was a fully developed branch of mathematics. Einstein says, I have curved space-time. Let me borrow some of that. He borrows it, slaps it in. Oh my gosh, it's working for him. It has the right mathematical tools to attach to his physics to make predictions, to make calculations. However, okay. He gathers a lot of mass into one place.
Uh-oh.
The curvature becomes severe.
Yeah.
And all of a sudden, in one of his equations,
the math goes to shit.
In one of his equations, he's got to divide by zero. Okay.
Uh-oh.
So you may remember from your middle school math or whatever, you can't divide by zero.
Right.
It doesn't work. Okay. The result goes to infinity if you divide by zero. So what that tells us is you can't blame the math for that because the math was doing just fine until he tried to make the math everything that his theory was. So something else has to change in the physics so that the math doesn't give you that singularity at the center of a black hole or at the Big Bang itself. That's where you're dividing by zero. Some have joked to say it's where God is dividing by zero. Well, no, God would probably have an understanding of the universe where that's not even necessary.
Right.
Right? That's the crutch that comes about when your idea of the universe is not completely all there.
Right. Yes.
So that's a case where the mathematical model of the universe got you pretty far, but there was a point where it broke down. And so you have to modify the physical model, get the math that would apply to that, and then continue on your way. So, in summary, when we describe physics with math, it is our best invocation of math as a representation of my model of the universe. And if it is perfect, then I can forever manipulate the math. And in so doing, I'd be manipulating the universe, taking my model to places that I didn't even know it could go.
Right.
So the math assures you that steps you take with that model are logically accurate for every next step you take. You can't just make stuff up. Once you go there,
I just didn't understand.
Yeah. So I mean, it's a fascinating fact that the math works at all.
Yeah.
Okay. There was a physicist, Eugene Wigner. I met him once. He was like, I'm coming up, and he's like on his way out. He was like 85. Eugene Wigner, I think he was a German mathematician, physicist, who commented on the unreasonable effectiveness of mathematics in science. It's just out there, and you just slap it into your idea, provided you did that right. You just calculate away. And quantum physics is doing that for us.
Yeah.
All the math of quantum physics, we take the math, manipulate it another way, we make a prediction, oh my gosh, it comes out to be true. That's what tells us that maybe the universe is mathematically constructed.
Okay.
And Max Tegmark, my favorite name of anybody's name.
It's a good name.
This has been a Max Tegmark production. Physicist at MIT.
Yeah.
He's been on StarTalk.
That's right.
He wrote a book called The Mathematical Universe, where he is exploring everything that you know, see, think, and do. If you can make a mathematical model of it, then he takes the next leap and says, that means you can program it.
Right.
Oh.
which is kind of why people say we could live in a simulation.
There it is.
For that reason.
If it's all
If it's all
mathematically
mathematical
programmable,
and
there it is.
programmable, why not? Why couldn't it be a simulation?
You just got to get the right math to go to the right theory of the universe.
Yeah.
And then you're all good.
Okay.
Plenty of theories work with a little bit of math, and they say, let's make another prediction from the math, and that prediction never came true. So they just threw away the model.
That doesn't work.
It just doesn't work. Exactly.
Cool.
All right, we got to call that. That's a wrap for us here.
Well, thank you, Dr. Tyson. Thank you, Lord Nice. I appreciate it.
Excellent. And were you coming in from where?
I'm snowed in Maryland at the moment.
Snowed in Maryland.
Snowed in
Ooh.
Maryland.
Got about 10 inches of snow and then about 12 hours of ice afterwards. So we've just got
Damn.
ice skating rinks outside.
Glad we can reach you.
Yeah, man.
All right. Glad you can reach us.
Be well.
All right. Stay warm.
Thank you.
Chuck, just love speaking to our supporters.
Yeah, I just love that they give us money.
and I like that people come from different walks of life.
Yeah.
So I like that.
Yeah, it's very cool. We have a very diverse and smart audience.
Smart. Yeah.
Yeah, gotta love it.
And when they put out their questions, it's like they thought about it.
Yeah, man.
Yeah. All right. Till next time, keep looking up.